48 years ago today, a tiny robot was lifted off the planet with a job that was supposed to take only a few years. Not one, two. That is the number of scientific ears it has left on this side of the solar system. And right now, those 2 ears are quietly listening to the spaces between the stars, sending back whispers that no other machine can ever replace. If that image of a single plucky robot still phoning home from beyond our little blue dot makes your curiosity spark, this channel was made for you. Tap subscribe right now and stick with me, because what we are about to walk through is the kind of real, careful science story you almost never see anywhere else, and the ending has a small twist most people have no idea is coming. Most people have heard the name Voyager, but very few know what it really is. Voyager 1 is a robotic spacecraft, basically a small robotic ship that flies through space without any crew of any kind. It was launched in 1977 from Cape Canaveral, Florida, the same sandy launch site where many famous American rockets have lifted off since the earliest days of spaceflight. The launch happened on September 5, 1977, on a powerful rocket called Titan 3E, and it rose into the Florida sky the way most rockets do, in a long, bright roar of fire and smoke. The original job was actually pretty simple. Scientists at NASA's Jet Propulsion Laboratory, which most people just call JPL, wanted Voyager 1 to fly past 2 giant planets, Jupiter and Saturn, take close-up pictures, measure what those planets were made of, study their magnetic fields, and then keep going. The whole mission was planned to last only about 5 years, maybe a little more if they got lucky. No one back then imagined the spacecraft would still be alive and sending real science data almost 50 years later, long after the engineers who built it had retired and some had passed away. When Voyager flew past Jupiter, it sent back stunning photos of the colorful bands of clouds swirling around the planet. It took the very first close-up shots of Europa, one of Jupiter's moons, which later turned out to hide a huge salty ocean under its icy crust. Then it flew past Saturn, snapping photos of the rings that showed thousands of tiny details no one had ever seen before. After that, the cameras and most of the planetary tools had done their main job, but Voyager kept flying outward, deeper, past the orbits of Uranus and Neptune, past the last known planet, and into the dark. Voyager 1 is now, and has been for a while, the farthest human-made object in the entire universe. Right now, in 2026, it sits more than 15 billion miles from Earth. To picture that distance, imagine the sun is a basketball sitting on your kitchen table. Earth would be a tiny green pea about 30 steps away from that basketball. Jupiter would be a smaller marble even further out. Voyager 1 would be more than 3,000 steps past that basketball, far, far away from every planet we know, drifting in almost total darkness. In 2012, something amazing happened that most people have at least heard about. Voyager 1 crossed the boundary out of the warm bubble of space that the sun blows around itself, called the heliosphere, and stepped into what scientists call interstellar space. That phrase simply means the space between stars. It was the first machine ever built by humans to leave our local solar system neighborhood, our little cosmic block, and it did so without ever changing its speed in any dramatic way. It just kept drifting, and one day it was on the other side. The actual proof came from the very instrument still running today. The plasma wave subsystem detected a quiet change in the vibrations of space, a small shift that scientists had been watching for, like a long hush after a busy wind. That signal marked the doorway closing between Voyager 1 and the warm bubble of the sun, and the doorway opening to the much colder unknown ahead. Nobody had ever caught that exact moment from a moving spacecraft before, and it happened almost without anyone on Earth noticing in real time. The data was interpreted months later, slowly and carefully, by a small team studying line after line of measurements. Right now, Voyager 1 is sitting in that cold, dark place alone. It has no headlights, no big camera screen, no pilot at the wheel. But it still has those 2 instruments that listen, and it still has a thin, dish-shaped antenna that points back at planet Earth. That antenna is so perfectly aimed, even after 48 years of drifting, that it can send the faintest whisper of a signal across the dark and have it actually reach the right place on Earth. To send a signal from 15 billion miles, Voyager uses a dish-shaped antenna the size of a large satellite TV dish. The signal it sends is incredibly weak by the time it arrives. In fact, the power hitting a telescope antenna on Earth from Voyager is less than a billionth of a watt. That is, trillions of times weaker than the radio waves your phone uses every single day when you load a video. The dot of power that finally lands here is so small that scientists describe it as a few watts worth of energy scattered across an entire continent of empty space. This is why NASA uses a special network called the Deep Space Network, sometimes shortened to DSN. The Deep Space Network is a group of huge radio dish antennas placed in California, Spain, and Australia, 3 spots carefully spread around the planet so that no matter how Earth turns, at least one of them is always pointing at Voyager. Those dishes work together, 24 hours a day, to catch the tiny whisper from Voyager and turn it back into useful data that scientists can study. The biggest of those dishes is wider than a football field is long, and each was built with surfaces so smooth they can catch whispers from across the solar system. The network sends powerful signals up to Voyager when engineers need to give it a command, and listens to the tiniest reply coming back down. The whole setup is one of the most advanced listening tools humans have ever built, and it is the only reason Voyager 1 can still talk to us at all today. Without those dishes working together, every word from Voyager would simply vanish into the radio noise of the universe and never be heard again. When Voyager 1 was first launched, scientists expected the instruments on board to last a few years, maybe 5 or so, maybe up to 10 if they were lucky, and if the radiation in space was kind. No one in 1977 built anything on this little ship expecting it to work for half a century. The technology inside is genuinely old by today's standards, and every part was designed to survive only as long as the original planetary visit needed. But the reality shocked everyone, and it still shocks people hearing it for the first time. Voyager 1 is alive and sending real data today, almost 50 years after launch. It has outlasted every expectation. It has outlasted the telescopes that helped aim it. It has outlasted its critics, who thought the electronics would die within a decade. And it has outlasted at least some of the very people who carefully soldered its circuits together with their own hands in clean rooms in Pasadena. Today, the average age of the engineers still working on the Voyager mission is well into their 60s and 70s. In 2024, though, something scary happened that almost ended the mission early. A tiny memory chip inside Voyager 1 suddenly stopped working. To be fair, this chip was 46 years old, which is longer than most of us have been alive. When this single chip failed, Voyager started sending garbage data back to Earth, basically nonsense. The signal was still arriving, but the data in it was meaningless. For about 5 long months, Voyager 1 was almost silent and almost lost. Some engineers feared the entire spacecraft might have to be declared dead. But here is one of the most surprising moments of the whole story. The engineers at NASA's Jet Propulsion Laboratory asked whether they could fix it without ever touching the spacecraft. Of course, no human could fly out and replace the chip. Voyager 1 is more than 15 billion miles away, and no rocket yet built could catch it. The engineers had to invent a brand new software patch from scratch. Then they had to send that patch as invisible radio waves across 15 billion miles of empty space, and the patch took almost a full day just to arrive. The patch was simple but very clever. It told Voyager to move all of the working parts of its computer program to different memory locations, carefully routing around the dead chip the way a driver steers a car around a pothole in the road. The engineers did this on a 46-year-old spacecraft, using code that was older than most video games on the internet. They did it from a building in Pasadena, California, with no ability to peek inside and see what was happening. And it worked. Voyager 1 began talking clearly again, sending real, sensible data for the first time in half a year. This repair is one of the most amazing remote fixes in all of human history. Now comes the part that most people do not know. When Voyager 1 was launched in 1977, it carried 10 scientific instruments. These instruments combined cameras, magnetic field sensors, particle detectors, infrared tools, ultraviolet tools, and radio wave receivers. The whole point of the mission was to use every one of these tools to study the planets and the space around them. They were like a busy toolbox designed for one big job. Today, only 2 of those 10 instruments are still turned on. Let that sink in. Out of 10 original scientific tools, 8 have been switched off over the decades. The cameras were turned off first, way back in 1990, after the planetary mission was clearly over. Infrared and ultraviolet sensors went quiet in the early days of the interstellar phase of the mission. Several particle detectors were turned off one by one to save power for the ones scientists wanted most. After all those choices, 2 were left running. The 2 instruments still working on Voyager 1 today are the Plasma Wave Subsystem, often shortened to PWS, and the magnetometer, shortened to MAG. The plasma wave instrument listens for tiny vibrations in the gas of space, like a small ear held up against a windy sky. Most people have never heard it work, but the data it returns lets scientists on Earth figure out the density of the space around Voyager, which is something you absolutely cannot know any other way at that distance. The magnetometer measures magnetic fields, the invisible forces that stretch out from stars and planets across the vastness of space, and it has been working non-stop since 1977. And here is the detail most people have no idea about. Both Voyager 1 and Voyager 2 carry exactly the same kinds of instruments, like twins with the same toolkit. Voyager 2 is still working too, but it is closer to home and went a different direction outward. Voyager 2 has had similar instruments shut down at similar times to save power. So when Voyager 1 loses an instrument, we already have a sense of what is being lost across the whole family of these little explorers. This matters deeply because Voyager 1 is our only messenger from interstellar space right now. There is no other human-built machine out there doing this work. No car, no robot, no camera. Just Voyager 1. Every day the two remaining instruments stay on, we get a slice of data from beyond our solar system that we cannot get any other way. When the last instrument is turned off, that thin stream of whispers from outside our cosmic neighborhood will not be replaced anytime soon. It will simply stop. Think about Voyager 1 like an old grandpa on a long road trip, the only family member with eyes for the road. When he falls asleep and stops looking out the window, the family has to wait for the next generation to wake up and start looking again. There is no replacement in the car right now. Let me ask you something important. Knowing that Voyager 1 has been flying for almost 50 years and is still sending real science from outside the solar system, did you ever think a single robot could actually pull that off? Drop your answer in the comments down below because I genuinely want to know what you thought was possible before today. And if you are enjoying this story, go ahead and tap that like button so more people who care about real space science can find this video today. Now let me explain why the instruments are being shut down one by one, because the reason is interesting and a little heartbreaking in its own way. The reason is power. Voyager 1 does not have solar panels. It cannot because it is too far from the sun for sunlight to be useful anymore. The light out there is so weak that solar panels would generate almost no electricity at all. So Voyager 1 carries a small nuclear power plant called a radioisotope thermoelectric generator, usually shortened to RTG. An RTG turns the heat from a slowly decaying piece of plutonium into electricity, sort of like a hot potato slowly charging a tiny motor over many decades. When Voyager 1 launched in 1977, its plutonium power plant produced about 470 watts. That sounds like a lot, but it is actually less than what a typical home toaster oven uses to make breakfast. As the years passed, the plutonium kept decaying through the laws of physics. Today, that same power plant produces only about 225 watts. In other words, the power has been cut almost in half over 48 quiet years. The drop is slow and steady and unstoppable. Every single year, Voyager 1 loses about 4 more watts of usable power. That number sounds tiny if you only think about home electricity, where 4 watts would barely light a small nightlight. But on a spacecraft where every single watt must be carefully rationed, 4 watts is huge. 4 watts can be the difference between keeping one scientific instrument alive or having to shut it off forever. 4 watts is the price of keeping a tool running, listening to space, sending back real science. In February 2025, NASA turned off one of the most important instruments on Voyager 1. It was the Cosmic Ray Subsystem, shortened to CRS. This instrument had been measuring high-energy particles hitting the spacecraft from distant exploding stars and from the sun itself. It had been working for 48 years straight, since the very first day of the mission. Turning it off was a hard decision. Every engineer on the team knew that losing it meant losing that specific kind of measurement forever. There was no way to turn it back on later if power got better. In March 2025, NASA turned off the same kind of instrument, called the Low Energy Charged Particle Subsystem, or LECP for short, on Voyager 2, the twin sister spacecraft. Then, in April 2026, engineers at NASA's Jet Propulsion Laboratory turned off that very same LECP instrument on Voyager 1 as well. That shutdown took 23 hours just to send the command across space, and then another 3 hours and 15 minutes to actually carry out the shutdown itself on the distant spacecraft. After that, Voyager 1 had only 2 instruments left. Why did they shut these instruments off when they did? because the overall power level finally dropped below the amount needed to safely run all remaining tools at once. NASA's engineers had to make a real choice. They chose to keep the two most scientifically valuable instruments alive and turn the rest off. It was not a careless choice. It was a careful calculation. They picked the instruments that could still teach humans the most new things. Now here is something almost nobody outside of space science has heard about, and it is one of the most creative ideas in this whole story. NASA engineers have come up with a clever plan they call the Big Bang. The name sounds dramatic, but the idea is actually pretty simple when you hear it. The heaters in certain electrical systems on Voyager 1 use up small amounts of power even when they are not strictly needed for science. The engineers want to turn some of these off temporarily to free up power for other parts of the spacecraft, especially the bits that keep the antenna pointed at Earth. But there is a real, scary risk. If the fuel lines inside the spacecraft get too cold, they could freeze, and that would mean losing the ability to point the antenna back at Earth. Once the antenna is no longer pointed at us, the conversation stops for good. Voyager would go silent forever, drifting endlessly through the dark. So the engineers have to be very, very careful. The plan is to do a careful experiment on Voyager 2 first, because Voyager 2 is closer to home and a bit easier to reach with signals. If the Big Bang experiment works safely on Voyager 2, NASA will try the same plan on Voyager 1 a few months later. The hope is that this maneuver will buy the mission a few more precious years of life. The risk is freezing the very thing that lets Voyager speak to us at all. That is a huge bet for an almost 50-year-old spacecraft. Picture this in your head for a second. A robot that was built to last only 5 years is about to decide whether to gamble its last warm fuel lines on a tricky maneuver that has never been tried on a real spacecraft before. Would you take that bet, knowing you cannot go up there and check the lines yourself? Tell me yes or no in the comments below, and tell me why you would risk it or walk away. And while you are typing that out, hit that subscribe button so you do not miss the next chapter of this story when it drops. Let me share a small detail that almost nobody thinks about when they hear stories like this. The radio signal from Voyager 1, even moving at the speed of light, the fastest thing in the universe, takes more than 23 hours to reach Earth. That means every command we send up takes 23 hours just to arrive, and every bit of data Voyager sends back takes another 23 hours. Add the two together and you get almost 2 full days for a single round trip between Earth and the spacecraft. You cannot have a real conversation with Voyager 1 the way you can talk to a friend across a room. If you sent it a question at noon today, the answer would not arrive until the day after tomorrow at the earliest. This is what engineers call light speed delay, and it is one of the biggest reasons space feels so strange and lonely for the humans who control these missions. You press a button on Earth, and then you wait almost 2 days to find out what happened. Nobody really knows the exact day Voyager 1 will fall silent. NASA has been careful about giving a specific date because every clever software trick and every pulled-off instrument changes the math. But the most common estimate you hear from senior engineers is that the mission may finally end sometime around 2030, possibly slipping into the early 2030s if the Big Bang maneuver works. That gives Voyager 1 maybe somewhere between 3 and 5 more years of real operation before the power drops too low to run anything meaningful. The exact number keeps moving around. If the upcoming Big Bang test works and the gamble pays off, the mission could stretch a tiny bit longer. If the gamble fails and a fuel line freezes, the clock speeds up fast and the end could come more suddenly. Remember, Voyager 1 was only supposed to last about 5 years when it was launched. We have already gotten close to 10 times that. But the math is finally catching up with the mission. The plutonium is decaying, and there is no way to slow it down or speed it up. One day, maybe in the early 2030s, Voyager 1 will send its last faint whisper back to the Deep Space Network dishes, and after that, it will keep flying forever, but never speak to Earth again. Now picture a beautiful and slightly sad scene. Voyager 1 is carrying a gold-plated copper record called the Voyager Golden Record. It is a phonograph-style disc, like the kind your great-grandparents might have played music on, but loaded with greetings in many human languages, sounds of Earth, songs from around the world, and even family photographs of human life printed onto the surface of the record. There is also a tiny needle and instructions on how to play it, in case any other living form ever finds this tiny traveler millions of years from now. One of the greetings on the record is a single human voice saying, "Hello," in a language unknown to most Earth listeners. The record also includes the sound of wind across an ocean, the sound of a kiss, the sound of laughter from a child, and the sound of a mother with her baby. Every track was carefully chosen by a small team led by the astronomer Carl Sagan, the same person who pushed the whole golden record idea through in the first place. The disc also carries music from Bach and from Chuck Berry, placed side by side on the same spinning groove, the strangest duet ever pressed into metal. Before the cameras were turned off for good, Voyager 1 took one more famous image on command. In 1990, engineers turned the camera backward, away from the cold dark of deep space, and pointed it at the planets it had been leaving behind for years. From that impossible distance, Earth showed up as a single tiny pale blue pixel, smaller than a grain of sand held out at arm's length. It was the farthest portrait of home ever taken, and Carl Sagan named it the pale blue dot. That little dot, he wrote, was everything any of us had ever known. Every joy and every sorrow, every life, every love. Voyager did that. Voyager 1 is the spacecraft that reminded us what home looks like from far, far away. If some other living thing, anything curious enough to fly through space, ever finds Voyager 1 someday, that record is the only proof that humans were ever here. The instruments are about to go quiet, but the record will keep drifting through the galaxy long after the last electric signal has stopped. The record is a kind of letter in a bottle, sealed and dropped into the ocean of space. Here is the part that makes this story feel urgent rather than just nostalgic. Right now, in 2026, 2 instruments on Voyager 1 are still streaming real data back to Earth. That data is helping scientists understand what is happening in interstellar space, a place humans have only ever studied from the outside, like someone standing at a window and looking out until now. There are no other spacecraft in interstellar space. There will not be another for many decades. So every single byte of data that comes down from Voyager 1 today is one of the only chances we will have in our lifetimes to peek outside the sun's protective bubble. Every reading from the magnetometer is a gift. Every quiet hiss from the plasma wave instrument teaches us something about what space is really like out there, far past the planets. Let me ask you a real question about all of this. If you could send one final command to Voyager 1 before it goes quiet forever, what would you tell it to do? Would you point the camera at one last look at Earth, or just listen to the silence for a few more years? Leave your honest answer in the comments below. And if you want to be part of the next story on this channel, tap that subscribe button and turn on the little bell so you never miss the next upload. Everything NASA does with Voyager 1 today is a kind of careful magic. They have to share precious power across dozens of small electrical systems. They cannot waste a single watt. They have to plan weeks ahead for every command, because round-trip message time is almost 2 full days. There is no quick fix. There is no rushing to help. Every move has to be thought through. They also have to keep temperatures steady. Voyager 1 sits in deep cold, much colder than any winter on Earth, and some parts of it would freeze up without small electric heaters running. Engineers have slowly lowered the heater settings over the years to save more power. They have changed the software multiple times. They have rebooted instruments that got stuck. They have done absolutely everything they can to squeeze just a little more life out of this tiny explorer, every step of the way. Some scientists call Voyager 1 the loneliest object in the universe. After it stops sending signals, it will still keep flying outward at the same speed, never slowing down, never stopping, but it will be completely alone in its work. It will not be able to send anything. It will not be able to hear anything. It will simply drift through empty space forever, like a message in a bottle that never touches a shore. That loneliness is the kind of thing humans have a hard time understanding. We are used to quick replies and constant connection. Voyager 1 shows us a different kind of existence, where signals travel for a whole day, where machines slowly age and fade, but never really stop moving. Thank you for staying with me all the way to the end of this story. Voyager 1 is still talking to us from more than 15 billion miles away, and as long as it is still talking, we should keep listening. I will see you in the next one.